Assalamualaikum and hi. I am Ainaa from M12. So we're going to discuss about past year KMPK 2021. 2000/21. So the first question is an aqueous solutions contain 167 gram copper sulfate in an 820 ml of solution. The density of the solution is 1.195. Calculate the percentage by mass copper sulfate and then molarity of the solution. So the information given is the gram of copper sulfate, which is 167 gram, and the volume solution 820 ml, and then the density is 1.195. So we need to know who is the solute in this question. So the solute is copper sulfate and the volume solution is 820 ml. So we need to use the percentage by mass copper sulfate, right? So the percentage, the formula is percentage equals to mass of solute, which is 167, and the mass of solution times 100. So do we know the mass solution? No, right? We don't know. So how we're going to find it? We're going to find it through the formula of density. So first step, find the mass of solution. And this density formula is mass of solution, which is in gram, volume of solution in ml. So the density already given, which is 1.195, equals to mass of solution over 820 ml. So the mass solution we already get 979.9 gram. And then after we get the mass solution, we're going to substitute it in the percentage by mass, which is mass of solute over mass of solution times 100. And 167 is the mass of solute, and then 979.9 is the mass solution. And then after we calculate, we get the percentage by mass, which is 17.04 percentage. And then the second question is molarity of the solution. So first step, we're gonna use the formula from the triangle, which is mass over molar mass. So mole of copper sulfate equals to 167 over the molar mass of copper sulfate. Also, how we're gonna find the molar mass, which is we already know. We can take it from the atomic relative mass at the table given in the page. So after we calculate, we can get what are the mole of copper sulfate, which is 1.0477 mole, and we need to place it for 4 decimal places lah. And then the second step is find the molarity. So what's the formula of molarity? Molarity is mole of solute over volume of solution. So mole of solute we already know, which is CuSO4. We already get the mole from this. And then over the volume of solution. So the volume of solution is already given, which is 820 ml. But it's in ml, so we need to convert it into liter. So we substitute all the information we already have, and then we will get the answer is 1.28 molarity. And then B question, it say methyl alcohol is produced via the reaction. So this is the balance equation lah, already given. And then a mixture of 1.2 gram hydrogen and 7.45 gram of CO are allowed to react. So first it says determine the limiting reactant. So first step, we need to write the equation balance. We need to balance the equation, which is have one coefficient and then two coefficient of 2 mole of H2. So we call this as coefficient. So first step, find mole for each reactant. So the reactant is CO and hydrogen, right? So we already find the mole, and mole for CO will get 0.2661 mole given and 0.6 mole given. So this is from the experiment, okay? And that's the second step, compare each reactant to get needed mole. So we already know the coefficient from the equation balance, right? Which is 1 mole of CO reacts with 2 mole of hydrogen. So the mole for CO is 0.2661 mole of CO react with hydrogen, which is 2 mole. So times 2, and then we will get the needed mole of hydrogen. So in my case, I always remember bahagi dengan diri sendiri, and then darab dengan jiran sebelah. So CO ni dia bahagi dengan diri dia sendiri, and then dia darab dengan jiran sebelah, which is hydrogen tu ada berapa mol? Ada 2 mol kan? Coefficient mol dia ada 2 kan? So darablah dengan 2. And then same goes if you are student macam tak pandai lagi nak buat limiting reactant, for me I would do for both needed mole for each reactant. So 2 mole of hydrogen with and then reacts with 1 mole of CO. 2 mole of hydrogen, which is 0.6 mole, divide by himself by hydrogen, which is 2, and then times with 1, and we'll get 0.3 mole of CO needed. And the second step, compare each reactant between given and needed. So the given mole for CO is 0.2661 is less than 0.3 mole needed of CO. And then the second statement is 0.6 mole given H2 is more than 0.522 mole of needed H2. So in limiting reactant, how to identify is by the given need to be less than the mole needed. So which one is the limiting reactant? Of course lah, CO would be the limiting reactant. Thus, we can conclude that CO is a limiting reactant in this question. Okay, and then the second question, next question, a mixture. Okay, we already know the limiting reactant. And second question, it asks what is the maximum amount in grams of CH3OH that can be obtained. So what is mean be obtained and maximum amount? So it says maximum amount, right? So it wants the limiting reactant. We need to use the limiting reactant since the limiting reactant will produce the maximum product. Okay. Okay, and then the first step is find the mole of CH3OH. So from the equation, we already know 1 mole of CO reacts with 1 mole of CH3OH. And we can use these steps, which is bahagi diri sendiri and darab dengan jiran sebelah. And then we will get the mole of CH3OH, which is the product, is 0.2661 since the coefficient of each of the reactant and the product is 1 coefficient. So, and then the second step is find the mass of CH3OH. So, how to find? The formula finding mass is mass equals to mole times molar mass. Molar mass we already know from the table given, and then the mole is we already calculate, and then the final answer would be 8.52 grams. Sorry. Okay. Third question, calculate the mass of excessive reactant that is left after the completion of the reaction. So how to find how to do with this kind of question? Okay, first step, find hydrogen mole excess. Okay, we already know, right, the mole given we get from the first time we calculate the mole, which is this one, the mole given, right, from the mole given from the experiment. And then the mole used, so the mole used means the mole needed lah, the mole needed that we already calculate. And then after we minus mole given minus mole used, we will get 0.1478 mole. And the second step, find the mass excess reactant. So the mass is mass time mole equals to mole times molar mass. From the, you can use this triangle because it's really help for us, especially student. So the mass of hydrogen is 0.30 gram. Okay, I think that's all from me. Thank you.